Hello, welcome back to Cracking the Cryptic and a puzzle by Willpower today, a regular poster on Logic Masters Germany, almost never at the harder end of the scale, and the puzzles are lovely and they're often very visually arresting, just like this sort of staircase of pills and arrows is. We will have a look at the rules in a minute. First of all, I do of course want to tell you all about Patreon, where the August, I'm trying to remember the month, the August monthly reward is the Labours of Rostam, the ancient Persian hero. We've got a bit of poetry, we've got a bit of Sudoku for you, and a few entertaining puzzle ideas that we hope you really enjoy. Do check that out if you're with us on Patreon, where, of course, there is all sorts of other stuff like crossword videos, me racing, where Simon's masterclassing, for instance, where there's connections videos and loads of extra content. We do welcome you to our Patreon if you join it. I hope you will. Now there's also, of course, all of our apps, and they do feature Arrow Sudoku and Domino Sudoku and many others. Chess Sudoku, Sandwich Sudoku, Classic Sudoku, and Fog of War, and of course the Worms by Marty Sears and James Sinclair. Do check those out. They are great fun and proving very popular. You can also look on the links under the video to find your way to SVEN'S SUDOKU PAD and support that. Sven has a Patreon too. And of course, we welcome you to watch our videos every day. Crosswords every week, streaming on Mondays most of the time if we're not on holiday. Anyway, that's all going on, and yeah, we welcome you. Now, let's have a look at Will's rules. The puzzle is called Crystallization of Arrows, and one of the rules is a sort of crystallization rule. Let me explain. So first of all, normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Numbers on arrows sum to the number on the arrow's origin, which is a circle or a pill. So those 6 numbers add up to the number in this pill. Pills are read from left to right, so it's a 2-digit number. It could be 30, 34, and then those numbers would have to add to 34. Now, there's a crystallization rule, which is that pink pills are the sum of the 2 pills or circles below them. So here's one, that's the sum of the 2 circles below it. That's easy. Now, you might be wondering, is that the sum of the 2 cells below it? No, it's not. It's the sum of the circle and the pill that it's resting on. So if this is 15 here, and that's an 8, then the sum here is 23. And then the sum of this is 23 plus whatever that is. So it's a fascinating idea. Now, we've got white dots, and our numbers with the white dot between them are consecutive. Numbers with the black dot between them is only one of those, are in a ratio of 2 to 1. And those are the rules. Give it a try. You can check the video length to see how hard this actually was. We had a correspondent who recommended this with the one adjective for the puzzle: lovely. So let's see if it is a lovely puzzle. I'm sure it will be. Let's restart the clock and let's say, let's get cracking. Okay, so let's start with this pill, which we are told is the sum of these 2 circles. Now, they obviously can't be more than a 9 and an 8 because they're Sudoku digits in the same row. So this can't be more than 17, and we can write a 1 in there. Now, am I right in thinking, not quite. I was going to say that this ascending ladder of tens digits must ascend all the way up, and that's definitely not right. And in fact, there's much more variation than my brain initially thought. So let's imagine this was as little as 12, and that was a 3. Then this would be 15. That's perfectly plausible. So you'd have a 1 here. I also think there are ways that, I was thinking this could be a 3. No, that's probably wrong. The maximum you could have here is 19 and 8 is 27. So this goes up in steps of 0, the tens digits I'm talking about, go up the ladder. They increase in steps of 0 or 1. Now they must increase when they're in the same box because those digits effectively see each other. So I don't know, I mean I could fill in that that is 1 or 2. This is 1, 2 or 3. Let's allow it to perhaps be a 1. Okay, now I've just discovered it's not worth doing that pencil marking. I'll do that one, but no others. Okay, let me think instead about these arrows down here. Those 3 digits add up to whatever this... Oh, those 2 are consecutive numbers. Ah, that's good. Right. So imagine that was a 6 and this was a 7. 17 equals 6 plus 11. Well, that won't work. So this must be lower than that. And if it was 16 equals 7 plus 9, I think we're always going to get a 9 here. If that's a 3, this is a 2. Okay, this isn't a 3 or a 4 because its arrow can't have a 1 on it. So this is 5, 6, 7 or 8. And if we add 9 to those digits, we get 14, 15, 16 or 17. Now, if that was an 8 with a 7, oh yeah, we could still make up this arrow. Okay, I don't quite know what I'm achieving at the moment. So this is 14, 15, 16 or 17, and we're going to add something from here. That hasn't changed whether this is 1 or 2. This pill is the sum of these 4. Some circles and pills, it did say, do not have an arrow. I mean, they're only forming their... Did I read that out? I don't know. I hope I did, but I might not have. But it's in the rules. So these circles don't have to have an arrow. In fact, these ones don't have an arrow. They're just pass-throughs. Actually, this is something to think about. What is the total here? The total of these digits is no more than the total of 9876543, which is 42, plus whatever is there, which is not a 9, makes 50, the maximum for this arrow. It can't be 50 because we can't put a 0 in, so the maximum for this digit is 4. And now I think that is quite interesting because we have to have an increase in the tens number when we go there, and we have to have 1 when we're here. So this digit is 1, 2 or 3. It can't be 1 because there's an increase in the tens number going up the ladder here. So yeah, that is right. Okay, this is 2 or 3. This is 2 or 3. We're changing box, so we don't need to change. This is 1 or 2, which is the same as that. Right. Now, I know that this is not 2 there and 1 there, because what would you put in this cell? So this is a 2. This is a 3. And now we can go 3, 3, 4. And adding this maximum arrow really helped. I'm glad I thought of that. Right, that 3 is on a black dot. We know that this arrow adds up to 46 now. And 46 is also the sum of 30 something and something. And I think that means these two cells have to add to 16. So they're a 9-7 pair. Now, 37 or 9... Well, okay, this is quite interesting. 30 something plus that equals 30 something, which plus that equals 37 or 9. So this digit plus this digit plus this digit equals 7 or 9. Oh, this is, sorry, I've just seen the white dot makes this a definite 1. That's not going to aid the campaign here. That means these two add up to 6 or 8. And there are actually various ways of doing either of those, which is a surprise. Now, what of this pair on the white dot? They're not a 1-2 pair, because that digit can't be either of them. And therefore, I can tell you there is an odd digit on the white dot, because every white dot has one odd and one even. The odd digit on this white dot we've just discovered is not 1. According to the row, it's not 3, 7 or 9. The odd digit on here is 5, and the even digit is either 4 or 6. Now we know 2 possibilities for the total of these 4 digits. And we can start either by saying the remaining digits in the row are 1, 2, 8, and 4 or 6, or we could do it by the secret. But let's do it by 1, 2, 8 equals 11, plus 4 would be 15, plus 6 would be 17. So we've got 15 or 17 here. That means these 2 cells, to get up to the total of 31, add up to 16 or 14. That wasn't quite as helpful as I expected. Okay, I thought we were going along nicely. (31) equals 20 something plus something. These 2 somethings, I'm going to make them yellow, have to add to 11, and we can't use 2 or 3. So they're either a 4-7 or a 5-6 pair. And then we're going to get to this, which is at least 34. 31, so that can't be a 2. But it can't be more than, I suppose it could be, well no, it can't be more than an 8. This can't be more than an 8, because 38, if that was what it was there, plus that equals 30, whatever this is. So this is no more than 8. These 2 are going to make either 7 or 9. I don't know, it's not quite enough to do this. Maybe. I was wondering about adding up the whole central box. The secret I nearly shared with you a moment ago is that the sum total of every row, column and box in a Sudoku is always the same number, and that number is 45. Because that's the sum of the digits 1 to 9, and by rule they have to appear in every row, column and box. But I don't know quite how it's going to help us. Okay, let's look at this digit, which can't be 3, 4, 6, 7 or 9. Now, this arrow has to add to 46. That's got to include all these green digits and that one. What do the green digits add up to? 45 for the column minus 4 is 41, minus some number there, plus some number here equals 5 to take that 41 total to 46. So what am I saying? This number minus this number equals 5. Let me just check what I'm doing here, because I'm confusing myself a bit. 46 the total. 45 the total for this column. So there's a 1 difference between this arrow, which is bigger, and this column, which is 45. And if we eliminate these equal digits, this digit is 1 bigger than these 2 added together. So that is not 5 or 8. These are either 4 and 1 leading to a 6 there, which is impossible. So they're 4 and 2 leading to a 7 here. And I think that must be right. Now, let me check the maths on that. That's 6. So these add up to 39, plus the 7 is 46, which is the number we need. So that's correct. We get a 7 there and a 2 up here. These remaining digits in box 1 are 158. No, these, we've used 2 and 4. Either, these can't be, we can't put an 8 in the middle because these would be 7, 8, 9, and that would break this cell. So if the middle digit is even, it's a 6, and this is 5, 6, 7. The alternative is that there are 2 even digits on this run of dots, and they are 6 and 8 on these positions, and that's a 7. So this is either 6 or 7, which is the second use of 6 or 7 in the row. And these are either a 5, 7 pair or a 6, 8 pair. This digit can't be a 7 because it's already in the box, so this one's not a 5. That can't be a 3, so there's a 3 down near the bottom of the column somewhere. I have a feeling I'm just asking mostly the wrong questions in this puzzle. I think that ladder thing was quite good. After that, I have not covered myself with any brilliance. Right, 31 plus this equals that. Well, that can't be 34 anymore then. This is going to need this to be 4, 5, 6, or 7. Ah, but 7 is the odd digit on that white dot, according to my pencil marks. What's the odd digit on this white dot? It's not 7, which is in one of those cells, or 3. It's not 1, because 2 would have to be on the white dot, and it's there. So the white dot digit here is either a 9, and this is a 9, 8 pair, or it's a 5. Ah, the 5 might be problematic. Wouldn't all these 5 digits be from the set 4, 5, 6, 7? They would. And that's impossible because there are only 4 digits in the set 4, 5, 6, 7. If 5 was the odd digit on this white dot, it would either be a 5, 4 pair here, that would make this 6 and 7 and break this, or a 5, 6 pair here, which would make that a 7 and both of these would be 4s. It's not possible. So the odd digit here is a 9. This is a 9, 8 pair. That is not an 8 now. This is a 7, 6 pair, and this is 5 or 8. In this box, we've got 9, 8, 6, 7, so that's not a 6. Now we're adding 31 and 4 or 5 to get 35 or 6 here. 35 or 6 plus what to get to that? Well, somewhere between 1 and 4. So this is a 1, 2, or 4. In this box, we've had 6, 7, 8, 9, 3, 2 and 4 there. This is 1 or 5. And this digit, 2, 4, or 5. Now I'm wondering if I ought to be adding up this arrow. We've already got, I don't know, there's so much variability at the bottom. I'm not keen to spend time doing that. I'm already getting a little bit confused inside my poor sore head. Okay, let's have another look at this row. 8, 9, one of these is 6 or 7, and that's the other one, and 2. So we're selecting from 1, 3, 4, and 5 over this side. That one can't be a 1. Okay, if this was a 1, that would be 2, and that would be 3, and that would crash. So no good. This is 3, 4, or 5. No, I don't know. Maybe I should be adding up totals for boxes. That's confusing. This is lovely, isn't it? It really is a clever piece of work. And it's a very interesting rule set, which I thought gave away a lot, but it really doesn't. 37 or 9, 35 or 6. Oh, that's interesting. Right, one of these two is a 5, because that's either 31 plus 4 equals 35, or 31 plus 5 equals 36. If one of those two is a 5, that can't be a 5, because it sees both cells. So that must be a 1. I don't know, I find that quite interesting. Maybe it's not. Maybe it's just me. Now we've got 30 something plus an even digit equals an odd number. So the 30 something must be an odd number, and that digit becomes a 5. This pair of yellows, which had to add to 11, is now 4, 7. It can't be 5, 6 anymore. This digit becomes a 6. This is 7. We know the order of this white dot sequence. We've got a 7 there. That's going to clean up the 9, 7. That was a huge breakthrough from spotting those two looking at that, and one of them having to be 5. Brilliant. I mean, I'm pleased we spotted it. And maybe it's not the official way through the puzzle, but it's a really neat one. Right, these remaining digits are 6, 8, and 9. It hasn't cleared up what that white dot is, which I would like to know. Now, 31 is 24 and 7, or 27 and 4. This is either 24 or 27. Now, if it was 27, I don't know, it doesn't really inform me much about these. That's irritating because I thought it was going to. Okay, what about this arrow? Can't have a 7 on it. That's not very much. Information. Oh, 37 equals 35 plus 2. That's very clear, sorry, didn't spot that. Then we've got, now 37 equals 2 plus 17, that's 19. Plus that is going to leave either 14 or 13 for these three. Oh, they're very middly numbers. Yeah, so I don't know what to do about that. 24 or 27 for this arrow. Oh, this can't be 5, but there is a 5 on this white dot, so it's there. Now one of these two digits in column 6 is a 5. If that's a 5, this is a 4. If that's a 5, this couldn't be 14 plus 5 because we can't put a 9. Couldn't be 15 plus 5 because we can't put a 0. Couldn't be 16 plus 5 because we couldn't have a 1 here. And it couldn't be 17 plus 5 because that would make this 22. So none of the plus 5 options work, and that's not a 5. And this is a 5 on the arrow with a 4. This digit is not 5, so that's not 4 above it. This is not 7 because of that. I hadn't seen that coming. So this is definitely odd. This is even. And this is 15 or 17, plus that equals whatever's going on up here. Plus that equals 24 or 27. I just don't know which way it's going. I don't even have hunches about these things. I just have to work them out, which is fair enough. In this row, 7, 4, 5, 9. The 1 is in one of those two cells. The 2 could be there. Don't tell me, this 4, 5 didn't really do anything at all. Right, here we're selecting from 2, 6, 8, 9. Now, this is a white dot, and there are very limited ways this can connect. That is now 2 or 6, this is 3 or 5. And it either goes 3, 2, 1 as a sequence, which it can't do, so it goes the other, 5, 6, 7. And that must be right. Now, we can take 4 out of those cells, and we've only got one candidate here. 3 and 1 are resolved. We can take 6 out of these. There's got to be a 4 here. Oh, what about this arrow? We've got 10 in the full size digits, so we're looking at 12, 18, or 19. So we're starting with a 1. And this is 2, 8, or 9, and it can't be 9. So that's 2 or 8, same digit as this. And now, if it was 12, this sum wouldn't work. 15 or 17 plus anything. So that's an 8, that's an 8. Now we're moving along. Right, no 9s in those cells. These two are 4 and 9. Now I can add up this arrow completely. 13, 15, 24. That works, which is pleasing. 24 is 18 plus 6. 18 is 15 or 17. It can't be 17 plus 1, so it's 15 plus 3. And 15 is 9 plus 6. Oh, I can fill in this one as well. 35 minus 31 is a 4. So we've crystallized the whole arrows. Now, this 37 is 7 plus 17, that's 24. These three add up to 13. 7 is placed in this box. These are 2, 8, 9. Ooh, well that's not a 9, 8 pair. If these three are adding up to 13, there's a 2 in those cells. And this one can't be a 9, so that's an 8. That's 2 and 9. This must be another 2. I'm going to check the maths one more time. 11, 13, 35, 37. That's it. So that 2 fixes 9 and 2 there. The 3 has fixed 8, and we get a 3 in the corner. That's 3 in the corner. That's 3 in the spot. Light losing its religion. That's a 4 on this arrow. This is a 9, 6 pair. In they go. That's a 4. We've sorted out 8 and 9. This is 7 and 3. We've got a 4, 9 pair up here. That's definite. And 8, 6. Now, we've just got the top 3 rows to go. This digit, we don't know. But we can add up. 31 minus 14 means these add to 17. They include 1, 2, and 8, which add to 11. So they must include a 6. In fact, we know where the 6 goes because I can see 6s in the columns below. That's the 6. That's a 4 now. 1, 2, and 8. The 1 must be here. That must be 2. That must be 8. All our arrows are done. Now it's just a bit of Sudoku to finish off. So 1 and 6. Oh, these two can't be 1, so that's 1. There we go. Now, in this column, 3 and 9. In this column, 2 and 7. We can write those in. In this column, 7 and 5. Now we can write those in. Then we get the 5, 8 done. This column needs 3 and 4. This one needs 9 and 8. And then we've just got the one we left over to do. There we go. We have crystallized our arrows using our willpower, and we've got it correct. Solve counter 100 at the moment. It's a lovely puzzle. I'm very pleased to have had the chance to do that on the channel. And thanks for the recommendation, Mr. Recommender. And we will see you guys again for more Sudoku tomorrow. It might be more difficult than this. It might not. You never know what you're going to get, like a Forrest Gump box of chocolates. Thank you for watching, and see you again soon. Bye for now.